Okay, so again, welcome back. So what we are doing at this channel is we recreate a Zelda-like game. We learn how to make a game with the Unity engine, and we are using the programming language C# to do that. And let's see what we did so far. Let's press play here. I mean, it's only 2 weeks in now, but still, we already have our character. And we have this amazing, beautiful art by Jessica, and she even has some new stuff for us in store today, so I will show that off later. And yeah, so the first week we basically made our character move, and in the second week we taught him how to animate, basically, so he walks properly. And last week we also added physics to the game so that we can crash into stuff and not walk through it. And yeah, that was basically what we did last week. And this week, the plan for this week is that we want to make stuff interactable. So as you can see here, we have a shield. We can read that shield maybe. We also have a chest, and we want to look what's inside the chest. So we want to code the functionality so that we can open the chest and get what is inside it. And then also I want to show off some of the new art that we got and that we can use for today. And let's start with the environment stuff. It's really beautiful. So first of all, let's start with the items. So today we want to add the functionality. Well, we want to interact with objects, and since we have a chest, we want to get stuff from the chest. So we'll be getting a shield. I hope you can see that here. But we have a nice shield here that we can attach to our character. We also have a sword that we want to get. But if you have played Zelda 3, you know that the sword is not simply in a chest. Getting the sword is a big moment. Not the first sword, but the Master Sword actually. And it needs a proper introduction and proper space. So we got that as well. Let me show this off because it looks so amazing. Let's go preview here. It's too big. Look at that. Look at that. This is our sword temple, whatever. I'm not quite sure yet. Let's call it. I'll call it a shrine, maybe. Yeah, it's the Master Sword Shrine, and the sword will be sticking here in the center. And then we can walk up to it, walk around it here, and then grab the sword. And to get the sword, we actually also need some new animation and stuff. So we have that as well. You can see up here we have lung attack, and we have some attack animation that the sword can be attached to, but I don't think that we will be using that today. That maybe for next week. What we're using today is those two animations on to the right here. So the first one is the iconic stance that Link does when he gets the sword. He holds it up for a second, and then there's a sound effect and stuff like that, and an animation. And whenever he gets a weapon from a chest, for now it will be the shield. He uses this animation to hold it up as well. So yeah, it's a nice proper reward for the player, just to have this awesome stance and show off what we got from the chest and stuff like that. So yeah, so we have those frames and those animations here. And one thing that we said last time that we also wanted to do, and I prepared stuff for that. So we physicalized all the objects here so we can walk through them, but the tree looks like you can walk behind it because it's very big. But right now everything is just blocking, so we can't walk behind the tree. But it's big. It's actually protruding out of the screen. So to speak, to fake our perspective, we want to be able to walk behind the tree here a little bit, maybe at this height, for example. And there are different ways to do that. Last time we discussed what ways there are, but we definitely want to do that. And the way that I chose, because it gives me the most control, is that I split up the tree into two different sprites. So I have the bottom half here, and I will make sure that our character cannot walk through this. And then I have the top half, and they will overlaid in such a way so you don't see that there are two halves, but the top half will be on another sprite layer, and this sprite layer will be rendered above our character. So our character basically can walk into it, but the tree will be drawn on top of it, so it appears like the character is behind the tree. And I think we start with that because that is quite a simple thing to do, and just gets our and let's remind ourselves how we set up the level and stuff. So it's a nice introduction for today's show. Okay, so actually let me set up this in a way. We put lighting down here, so because last time I was showing off something in the bottom left corner here, but you guys weren't able to see it because my camera is in the way. So let me put the project view over here to the right, and then I have a useless window, the lighting window. We don't need that, so I have this blocking down here, so I know that I'm not using this bottom left corner of the screen. Alright, so let's see. Our level basically is just the trees on the side here, and then we have stuff in the center. And we created some empty game objects so that we could group stuff together logically. So we have all the environment in one object, so basically we could move the whole environment except the active objects, because we're using those. But we have the trees in here, so we open this, we have big trees in here, and you can see we have tons of big trees here. So now we actually run into a problem, because we want to change the big tree, but we have 10 different ones, and they are all separate from each other. So when I change one tree, so let me show it off here. So if I tint this tree to make it a little darker, maybe it only changes for this tree, which is fine most of the time, or sometimes because you want to add some variation maybe. So you can have some color variations here so they all don't look exactly the same. But now, because we want to change the trees in such a way that that we can split them up, and we have to change all of them. And there's a way in Unity to do that. So but we have to set it up properly, and we didn't before. So we have to do this for all the trees now. Or we basically have to recreate the trees with the new method. So we want to have. So right now we have, for each tree we have a base object, which basically is the collider, and the collider tells us where we crash against, so that we can walk through it. You can see it with the green line here. This is basically what we collide against. And then we have the visuals object that we now want to split up into two objects actually. And because we want to do this for all the trees, we are going to use something called a prefab. And a prefab is a pretty cool concept from Unity. It's basically you can make an object and put all the scripts on there that you want and all the colliders and stuff like that, and then you can save this object in your project, so you can reuse it later, and it has the same base instance basically. So whenever you change the prefab, all the instances of that prefab change with it. So if we have a prefab for all the trees, we only have to change the prefab, and all the trees change at once. So let's do that first. We're using our first tree here, and then splitting it up. So we're picking the visuals, and instead of using the tree big sprite that we created before, I'm going to change that into the tree big one bottom. So because I have tree big one bottom and tree big one top. So let's change this to the bottom, which basically, oh, we have to, yeah, okay. So let's first, let's undo that. First, we have to set up the import settings properly. So as you can see, our old tree has a pixels per unit of 64, and the new ones, they always have a value of 100. That's basically the default unit for the default value for Unity, and you can change the default value through scripts, and it's probably a good idea that we create a script later on that does that for us, because otherwise we always have to change the pixels per unit every time we create a new sprite and import it, and we have to remember that we set the pixels per unit, but the script can do that for us. So, but for now we do it manually. Okay, so we set those to 64 as well. I had apply, and now we can change this to tree bottom. And you can see here, basically the tree got cut. And now what we do, we want to add a second visuals object. I just duplicated it with Control D or Command D if you're on a Mac. And then we call this visuals top. And I put the top visuals in here. So now it looks like the tree is basically, we have a complete tree again, but we have two separate objects. And so I could move the top basically separately. And what we can do as well is, if you remember from last time, we played around with the sorting layers and the order of these sprites. And this value basically tells Unity in which order it should render the sprites, which should be in the background, which should be in the foreground. And we have a sorting layer called GameObjects, which is and the bottom one, and right now all the trees were on the GameObjects layer, but we want to change the top part, so it's not on GameObjects anymore. We want it actually above the character. And we don't have a layer for that yet, so let's create a layer first. And we go to Layers on the top right, and we can click Edit Layers, and here we have our sorting layers. So we have GameObjects, we have our characters, and then we could have, I don't know, let's call it Hi Objects. Hello Soul Art, welcome to the stream. Yeah, let's call that Hi Objects. And we want our tree top to be in the Hi Object sorting layer. And because they're set up in this way in our sorting layer here, we can move them around, which one is on the top, which one's on the bottom. And so that it's actually a little backwards. So the layer that is above the topmost layer is actually the one that gets rendered the furthest behind, and then all the other layers coming after that will get rendered above that. So basically our Hi Objects layer is our highest layer right now, and everything will render behind the Hi Objects layer, all the other layers basically. Okay, so our visuals top, we have changed this to Hi Objects, and if we grab our character now, we just move him here for now, you can see that if we move him into the tree, he actually is above the tree at the bottom here, but once he gets to the top part of the tree, he gets obscured and the tree gets rendered above it. And that's what we set up. And now we can also change the collider of the tree to reflect that. Because right now, if you remember, our collider is set up to the complete tree here, and we actually now we want our character to be able to walk behind the top part here. So we change our collider, click on Edit Collider here, and change the vertices. I do it a little bit above the line, so that I'm sure our character is not sticking out of it, because that wouldn't look so nice. So let's put it this way basically. And if you want to delete some vertices from the collider because there are too many here, you can hold Control. I'm sure it's hold Command on the Mac. I'm not quite sure, but yeah, it's the same principle. So you hold Control and then left click, and you see it's colored red here, which means you would delete this vertex. And Yeah, and we put this over here as well. Perfect. So now our collider basically is just the bottom half of the tree, and our character would be able to walk against the top half here. So let's see how that looks. For now, let me remember, so the tree is located at -9 and 6, but I move him to the center right now so we can look how this works, and move our character back as well, and then hit play. Okay, we walk around. We are still colliding with the tree as expected at the bottom half here, and then the top half we can actually walk behind it. Nice. I mean, I actually don't quite like that you can hide completely behind it, because that could be, I don't know, a player might be able to get lost here. So let's change the collider of the tree a little bit, so it's a little bit higher. So whenever the character is behind the tree, you will always see at least the head sticking out at the top, just to have some visual clue where the character is. Okay, let's look here. Let's walk, and we can walk behind it, and then yes, we have always our head sticking out here. I think this is a good. We can move it down a little bit, so we can move behind it a little bit more. But yeah, this is just details now. It's really not that important. But okay, good. So now that our tree is complete and we have it set up in how we like it, we want to create a prefab from that tree, and so we can reuse that prefab over and over again, and don't have to recreate the tree every time. So let's move the tree back to the position where it was before. So there was -9 and 6. And we want to create a prefab. And creating prefab is quite easy. So let me create a folder for prefabs here. Prefabs, and then we have another folder in there, environment. And to create a prefab, you basically just drag the object from the hierarchy into the project view here. Just drag it to whichever folder you would like to have it, and then boom, a prefab is created for you. Couldn't you also only put the whole tree on the high objects layer and just adjust the collider? Yes, but it's true, but what we have, let me put this in the center again, but we set up our character in a way that the collider of our character is not the whole character, but only the feet. And we did that in order to create some fake perspective as well. So when the character walks in front of objects, you can actually walk into the objects a little bit, so it looks like the character is standing up. And the same thing works with the tree a little bit. You can see here. So the bottom half has to be rendered below the character, and the top half has to be rendered above it. That's why I did basically the two halves. But yeah, you're right. If we set up the collider differently, so that we basically stop here and we can't run into the tree, then we could just put the whole tree above the character as well. But yeah, this way we have basically two fake perspective techniques here. The character can walk into the objects, but the character also can walk behind the objects, which looks pretty nice, I think. All right, so let's move the tree back here. -9 and 6. Oh, that's the character. Wrong object. -9 and 6. Okay. And then the other trees are always 1 to the left and 3 units down. Okay. So let's delete all the other objects here, because we want to use the prefabs instead. So we have a prefab right now here, the big tree, and I call it big tree, not big tree L1. And basically the prefab has all the objects that that our tree has as well. And we can create a new tree by just simply dragging the prefab into the scene. And now we immediately have an object that is set up with the correct collider and the 2 visuals object, stuff like that. So basically you create a template that you can reuse later. And so let's move this to -10 and 3 and -10, please. Let's see how our and you can see in the hierarchy as well that the prefab objects actually are in a bluish color, so you can see those are prefabs and not singular objects like everything else here. Okay, so let's put the tree in here. And we can do that 5 times. This looks good. And then we duplicate all 5 trees and put them on the other side here. And then we have the same thing that we had before. Cool. So that's basically the tree. And now we want to get to the interesting part of today, and that is we want to interact with the objects. So because let's do some level design first, because we want to create our the objects, the sort location, the shrine that I showed you before. We want to add that to the scene here. So let's put this into the scene. Look at this. And we also need to adjust the pixels per unit for this, so it's the correct scale. Oh man, this is so beautiful. I'm really happy with this. And so you can see it's the correct scale. Our character fits perfectly into this little these little stairs here where he can grab the sword. But as you can see, this is a big object and it basically takes up it takes up most of the screen. I want to put it above our current screen and then add make it so that the camera moves as well. And we can do that with a very simple trick for now. Later on, if you remember from the game, the camera actually does some stuff. Whenever you switch a scene, it scrolls over. There are some borders where the camera cannot get above and below and stuff like that. So the camera actually has some logic to it as well, but we're not going to do that for now. We're going to implement that part later. For now, we just want to put the character in the center and follow the character at all times. Don't you normally want to reset the prefabs transform to 0, 0, 0? It doesn't really matter. I mean, the transform that is in the prefab right now, so we now have the -9 and 6 set here, and this value actually is only used if you instantiate the prefab through code. So if you have some bit of code that creates this prefab during the game, it will be initially created at this position -9 and 6. But you can move it immediately, and whenever you drag it into the scene, it actually gets created wherever you let go of your mouse, so the values don't even matter at all. So yeah, you could do that, but it doesn't really matter. Alright, so let's put the sword location out of the screen to the top half here, and then we want to give it a proper grid position. And then the simplest thing that we could do is that we just attach the camera to our character. So I put it in the center here because the camera is also in the center, and we can simply move the main character, the main camera into the character hierarchy here. And what that does is whenever the character moves, if we have hit play here, the camera moves as well. It's actually easier to see if we have the scene view. So you can see here, these are the boundaries of the camera. And when you move, the camera moves with us. And this is enough for now. As I said, the camera in Zelda has some logic to it, and we are going to focus on that later. But for now, this is enough. It just means that we can make bigger levels that are bigger than just one screen, which is all that we want for now. And yeah, so so we have to set up this a little bit, because right now we can just run over the whole thing and we don't have collisions here. So so we have to set up as well. The sprites look really nice. Yeah, I agree. Did you make them yourself? No. As Time Lord said, a friend of mine, Jessica, is creating them for me, and she will do many more, hopefully, so we can create an amazing looking game together. Because the goal here is not to have a tutorial, really. It's supposed to be a real game in the end, so you guys can see the whole process of it. We want to submit it to different stores, and I will do that on stream as well, and stuff like that. And I actually I put some information below the stream in the panels below, but for next time I have to include credits for Jessica as well. I think I forgot that, which is shame on me. Okay, I actually had another friend of mine create some original music for this as well, so later on we will put some amazing music in here that fits the theme very well. So yeah. Alright, let's continue. So for now, what we can do, we can create some more trees here, so that the whole level is basically surrounded by trees. Can do that quickly. And the cool thing is, if you remember last time, we had some problems with the sorting order because the roots were showing above the trees sometimes. But since we split the tree up now and the top of the tree is always on high objects, this won't happen again, which is cool. So one less thing we have to worry about. I think, yeah, put this here. I actually want to do this one layer higher, so we can walk behind this stuff as well. And let's make a border here. I mean, since the camera can now moves with the character at all times, we actually can look behind the trees, which is not super nice, but it's alright for now. We can fix that later when we do our proper camera. But that's basically a reason why the camera is the real camera is not simply attached to the character, but has some logic to it. Oh no, this is not working out how I wanted it to. So let's move all those to the left a little bit. I think one should be enough, should it? Okay, fine, two. So this way it looks nice, and now we can move all the big trees to the left a little bit so it is centered. Okay, perfect. And we also want to set up our sword shrine, and when you if you remember, I always want to have the visuals as a child, so I create a new GameObjects. It's actually easier just to duplicate this and remove the sprite renderer. This way they're in the exact same location. So we call this sword shrine, and put the visuals as a child here, and we call them the object visuals again. So this way we have our shrine here, we can move them a little bit, and now we can set up our colliders again, and we're again using polygon collider to do that. And actually for now, for this object we have to create two colliders, because we have the outer boundary right here, and we also have the inside that the character cannot walk over. And the character should is only supposed to walk from the top inside here. So we need two colliders. Let's start with this one here, and we do this really quick. Just have the outside here like this, like this. This is the cool thing about the polygon collider. You can simply click into an edge, and it creates a new vertex, which makes it very easy to modify this very quickly. And like this, like this, like this. So yeah. And yeah, once I'm done with creating the collider here, I have to go the other way as well. So It takes some time to set this up a little bit, but since this object is a little bit more complex, that is alright. And you can see here if you make a mistake like this now, so the edge is actually crosses your collider. So this would be an invalid collider. You can see the edge turning red. You can still set this. It's basically just a reminder for Unity that this is the weirdly set up collider, and you need to fix this. But yeah, no problem there. You can move this over here and then add this. And then the inside should be a little bit easier. Okay, it's up here, and then we go the same way back. But there are more straight edges here. Okay, after... Oh, this line was just on the inside, okay. So, the next thing that we want to do is, since we can talk a little bit about how we want to code these object interaction, because we have to think about that a little bit. Each scene can have multiple objects that the character can interact with. So we have the sign, we have the chest here, we have the sword stand up here, and there are several different add another polygon collider so I can do the center. There are several different prerequisites we have to meet before we can interact with something. The first one is that we have contact, or that we are very close to the object. So Link actually can only read the shield if he's he's just walking into the shield basically, into the sign, and then he can read it. So we want to make sure that the character is actually very, very close. We want to make sure that the character is facing the object that you want to interact with. So we have to check for that. And then the player has to press a button, of course, so that you can interact with the object. So those are the three different conditions that have to be met in order to interact with something. And I think this looks good. Let's test this out here. Just press play and see if this actually works. So perfect. So we can walk against here, past here. I mean, we could set it up in a way that we can walk into this stuff again, but since we're also walking over the object here, then we would have to split it again into a bottom layer and top layer, and I just don't want to do that right now. So maybe we can do that later, but for now the whole thing basically is blocking. And yeah, it works from the inside. We can walk into it, and this thing is blocking as well. This is our second polygon collider, and we can walk into... Oh, actually, I only want to be able to walk to here because the sword is sticking out of here. This is too far. But everything else looks pretty good. So let's edit this. No, this is the wrong one. I want to edit this one. So remove this, and move these two up a little bit, so we actually can only walk to here. Good. Okay, so in order to interact with objects, we need to create a code for this. So let's look at our character before, because we actually started to set this up last time a little bit. So let's go into our keyboard control script. Oh, I have it started up. Well, okay. Unity wants to start another instance of Visual Studio. So yeah, the first thing that we're going to do is we listen for keyboard input from the player. So let's just use the spacebar for now. I think we change it later because space, I think, is a better key for your attack move, but it's alright. Oh yeah, so we actually did that already. you can see here, this is not in the stream, right? I have to move this, make this a little smaller, please. And then move this over here. Good. So last time we actually started with this, so this is our keyboard control. In the update function, which is called every frame, we have a function named update direction, and this update direction basically listens for keyboard input WASD, and then if one of those buttons is pressed, then we want to move the character. And we also have the update action method, and this one listens for the spacebar. And there's a difference here, so we have input get key down here, and we have input get key down up here. And the difference is that get key is always true as long as the key is pressed. So if we hold down W, this is always true, and we move in the same direction. And the action button, this is get key down, is only true for one frame, and then it's only true again once you let go and press the button again. So that's a good distinction between the two. So basically, if the second the instance that we press the spacebar, we want to do this on action press function. And if I control click on the function name, I can go to here. And last time we started to set up a character interaction model, but we haven't done anything yet. Why did you not use the input get access input option? Yeah, Unity provides us an input manager, and I want to use that later. But for now, I thought explaining it, it's just more clear to explain what input actually does, because this is basically saying if the key W is pressed, then do something. I think for people who are not that familiar with Unity, this is just easier to understand for now, and later we change it to the more complex system that Unity provides for us. It's not really that much more complex, but still, yeah, we'll change it later. Okay, so on action press, and then we have another component that's called the character interaction model. And this component, we created this, and I think it's still completely empty. So this is where we left what we left last time. We don't need this for now. So what was this argument? Yeah, we'll change it later. We're going to use the input access later, and yeah, exactly, because I want to use different input methods for this game. I want to have like a touch input, like the on-screen controls you see in some games. I want to have gamepad input in here as well. So and once we get to that point and we handle all the different input stuff, then we update the code. For now, we leave it like this, so it's easy to understand. Okay, so the interaction model, basically, we want to create a function here as well and call it on interact. And this function is called, I have some naming conventions for my functions. So an on function basically is called whenever a certain event is happening. So I can put all the logic in here once something is happening. In this case, on interact basically will be called from our control class. You can see here we have on action pressed, which is basically one abstraction layer closer to the keyboard, because on action press sounds like, okay, the user has pressed something, and now we want to abstract that out further and basically decouple the action of pressing the button with the interaction. We have a class in between that, because then it's easier to change that class later and change different control methods. So we go from on action pressed, and then we call the on interact method from our interaction model. Okay, so and this is basically everything from our control. So we listen for the spacebar, and then we call the interaction model to do some stuff. We basically tell it, hey, we want to interact with some stuff. And then the interaction model will check what objects are there that we could interact with, and are the proper conditions met so that we can interact with them. So let's go into the model. Okay, now we need we basically need a way to check which objects we can interact with. So the objects themselves can say, I want the character to be able to interact with me. And we need to tell our interaction model, we need to tell our character that this is possible. So two different things. First of all, we will create a component. Let's just call it interactable. So this component is very basic, will be very basic. It just basically tells Unity, I'm a component, I'm interactable. Okay, and this is the beauty of the component model of Unity. Basically, what I would encourage you to do is create as many components as you can, and separate all your logic into single components. So being able to interact with an object, that is an interactable. Being able to destroy an object, that is a destructible, for example. This way you can later, whenever you create new objects, you can always throw, just willy-nilly throw interactable, destructible on there, and boom, you have an object that you can interact with and that you can destroy. You can also create a new object that is only interactable, for example, like the chest, but there's not a destructible on there, so this object can only be interacted with, but you can't destroy it. This is why it's good to have many different components for this, so you can just combine them as you like later on with all the different objects. Yeah, thank you, Timelock, for basically telling people while I'm explaining here. Awesome. And yes, the character is called Lunk. We can call it Link. Basically, my instruction to the artist and to the composer was, I want to have Zelda assets, but they cannot be Zelda because there are rights issues, of course. So the instruction is make it Zelda, but not Zelda. So this is why the character looks kind of like Link, but not really, because he has a different hair color, and he's also called Lunk. And yeah. And in the music as well, you will later hear that you have a melody line that is close to the one that we know from Zelda, but it's not quite the same. Yeah, that's basically the theme of this project. It's supposed to be Zelda, but since this is Zelda is obviously a copyrighted property for Nintendo, we just offset it a little bit, so we hopefully don't get into trouble. Okay, let's create the interactable component first. So I create a new folder here. Let's call it objects, and then we have all the object stuff in here. And we call this interactable. And now we can go to the chest, and we can add this interactable component into here. And once we coded this component, basically just dragging this component onto an object means you can now interact with this object. How you can interact with it is of course very different for each object. So we are going to handle that as well. But for now, we just want to say, yes, you can interact with me. Okay. So we could do different things now. So we are listening for the input as well. So already. So once we press space, our onInteract function method is called here. I sometimes call them methods, sometimes functions. To be honest, I think the names are the same. I think they're used in different programming languages, but they got mixed up in my head, so I don't know. I use them interchangeably. Functions and methods is the same for me. So we can see if this works by basically let Unity say something, interact stuff. So this is an awesome function from Unity if you want to have some stuff to check your code a little bit. You can have some debug output. Just call debug.log and then you can put whatever in here. And what this does is, wrong window. You see your console window in the bottom right corner here. If you don't have it in your code, this is basically the same that you have on the bottom here, and if you click on it, it opens. It can open the console. Oh no, it goes to the whatever the message is. You can open the console through window / where is it, at the very bottom. There. Go to window and then console, and then you open a console. And basically this is what debug log does. It basically calls the console. So if we press space, I don't want to maximize, I want to see the console. If we press space, it should show up here. So it doesn't, so that means we have something wrong in our code. So let's see what happens here. We have our character, we have our movement model, keyboard control view, movement view, and yeah, so we haven't actually put our interaction model on this character yet. So this is why the character it cannot be called, of course. So but the cool thing is, before I add this here, let me show this. So we are still, when pressing space, we are still. Why is this always going back? We're still going to the on action press, and we're calling on our interaction model, but we have a guard in front of that. So we're basically checking first, is there an interaction model at all? And if this variable is null, basically this means if there is no interaction model, if this variable is empty, then we return out of the function. We basically exit the function and don't do anything. What program are you using? You can see that below the stream. I'm using Unity as the game engine, and I'm using Visual Studio for our scripting environment, and we're scripting in C#. So yeah, so basically what this allows us to do is, we also have to search for the interaction model. This is another thing we have to do. So we have to get component character interaction model. Boom. But so if we don't find a character interaction model here, if there's no component like this on our game object, then basically this variable will be null, and we will exit this function. If we don't exit this function, I can comment that out here. If we just do this, and then we don't have an interaction model, we'll get an error message, which is not very nice. So let's press space now, and we should get, you can see here, whenever I press space, there's a new null reference exception. This is basically what that means. And you'll see this quite often actually, because this is a very common mistake. A null reference exception basically means you are trying to call a function on interact here, but this variable is null, so there's nothing in here. So you're trying to call a function on nothing, which is not possible. So this is called a null reference exception. The reference in this variable is null, basically. So, and this is why I put the guard in front of here. So I'm checking myself, is this null? And if this is null, then I want to exit out of it, so I don't get this error. And I'm doing this because I want to be able to reuse this component. So later on, I maybe want to have a character that can only move but not interact. Maybe we have a section in the game, a dungeon, where you cannot interact with anything, or there's a part in the story where I don't know, your hands are tied or something, so you can't interact with stuff. So you can just remove the interaction component completely, and the whole script still works and doesn't throw an error, because we're catching that here. We don't have an interaction model, so we don't want to do anything. Okay, so let's add our interaction model, because right now we do want to interact. And we can right click and move this up a little bit just have the scripts at the top. And now, when we press space, we should call the onInteract method, which in turn should throw a debug string saying interact. Let's see if that works. Let's spray here. Nah, I don't want to maximize for now. And then press space, and as you can see here, it says in the console interact whenever I press space. So this is a very handy method to check the flow of your code if it actually ends up where you expect it to, which is good. So this method is being called. Now we need to combine, now we need to be able to find all the interactable objects. So can you remember we put an interactable component on our chest, and now we want to be able to find the objects that have interactable components and then interact with them. And there are a couple different ways you could do that. You can search for all objects, and you can create a tag maybe and call this tag interactable as well. And you can search for, you have a function that basically says, give me all the objects with a certain tag. So you could do that, but I don't quite like that method because, wait a second, because you can only have one tag on an object. So you can't have an interactable tag and a destructible tag and stuff like that. And also it's basically redundant because we're adding a component here. It actually should already know that this is interactable. If we also have to set the tag, maybe we forget this sometimes, so this is a little bit error prone. So I only want us to have to create the interactable component onto a GameObject, and then that's it. This basically means this object is now interactable. There's another function in Unity that basically asks, give me all components of a certain type. We could do that as well. I don't like this very much as well. So the first method with a tag is find GameObject with tag. You can see them here. Find GameObjects with tag, and then we could put something in here, interactable tag, if we had set that up. This would be the first method, but we don't want to do that. The second one is find objects of type. We could do this and then find objects of type interactable. This interactable. This would return us all the components in the scene that are interactable. And this is actually what we want to do, but this method is very, very slow actually. And imagine you have a huge scene and there are hundreds and hundreds and hundreds of objects that you can interact with. This can get very slow, and so it doesn't scale very well. So I wouldn't use this method at all actually. As I said, it can get slow very fast. So this is not a very, very nice way to do it. Another way that we can do it, we can use so-called events and delegates. This is basically backwards. We are not looking for all the interactables in the scene. The interactables tell us, hey, I'm here, you can interact with me. This is basically a little bit backwards, but this is also a method. So, and this is the method that I like best. This way we can have a list of all the objects in our scene that we can interact with, and we simply have to, whenever the onInteract method is called, we simply have to look through our list and see which of these objects is close to us, which object is in which direction we are facing, and stuff like that. So this is very simple, and so we basically just go through the list that we already have, and this is a very nice model. So we need to find a way for the interactable component to tell our interaction model here that they exist, and we want to create a list for that. So first of all, let's create the list first. So we are going to use a new structure using system collections generic, and in this system collections generic namespace we can find the list type. The list type is basically, well, let me show you how this works if we don't put the using in front of here first, so I can explain how this works. So basically, the list type is in the namespace system collections generic and then list. It needs a template type in our pointy brackets here, and so we want to have a list of all interactables, and then we give this list a name. Interactables. But yeah, since this is not very nice looking and it's just cumbersome, and whenever you create a new list you would have to type all these stuff, you can actually put using at the top, using system collections generic, and now you don't have to type this every time. Basically the compiler knows that you are using stuff from the generic collection and it finds the references for you. It's just a shortcut basically. So let me see. Are we later on going to be implementing interfaces for these kinds of things as well, or are we going to write separate small scripts for each type of functionality? I ask because I can see it happen where some objects have another implementation of the same base functionality. It's true. I think usually the way I code is I don't plan ahead very much, which is odd if you think about it, but the most expensive resource when coding a game or coding anything is actually your time. And if you think too much about what you potentially need in the future and then you create like a system for it that it would be easier to use later, you are wasting a lot of time, because it's possible that you're not going to use that system anyway. So you created something that you're not going to use. And this is why I would basically rewrite my code if we get to that point where we have different objects that you can interact with. Then yes, then I would rewrite it. And we'll rewrite it in a second, because we have different interactables. We have a chest, we have the sword, we have the sign, stuff like that. But for now, the interactable is fine. Okay, so now we have a list of interactables, which is, and we have to create this list. So this variable would be null if you don't create it. So, but you can create it immediately here. So let's just put a new list interactable here. This basically says, as soon as this component is created, we want to create this list, so it actually exists, and it's not just a null variable. All right, now all the interactables have to tell us that they exist, so we can put them in this list. For this, we create a function, a public function, public void register interactable, and then we want to have a reference to the interactable. There's so much interactable in here, but yeah. And then whenever we register an interactable, we add this to the list. Basically, we want to check. Let's check first if it's already in the list, so we can avoid some errors later down the line. So if interactables contains, it's basically very simple. Let's rename this otherwise. Let's call this variable new interactable, so it's easier to see which one we have. So if the list contains new interactable, then we don't want to do anything, because we already have it. So in case we accidentally register an interactable twice, we don't have the problem that it's in the list twice and you would potentially interact with it twice, because it's in the list twice. Okay. And then if it's not in the list, then we want to add it to the list. Simply put add in here. And this is a nice thing. So maybe you know about arrays. And arrays are similar to a list. So we could also create an array of interactables. I always mistype this. interactables. Array is with the square brackets. We could also do this, but the bonus of the list is that you can stuff with add. So an array, you have a fixed size of it. You basically tell the compiler right now that this is an array of 10 objects, for example. But we don't know that. We don't know how many objects that they are in the scene. And you could say, well, just make the array like very, very big, like put 10,000 in there. But then you're wasting space, and also it like could potentially be 10,001 objects. So you don't know. So since we don't know, we want to have an array that just expands in size whenever the new stuff comes, and then the list is very, very, very easy to work with in that way. You simply create add, and it handles all the stuff of allocating space for it and making the list bigger if it's not big enough and stuff like that. So we don't have to care about that at all, which is nice. Okay, so we add it to the list, and we also need a way to unregister interactables, for example, if they get destroyed. So it's basically the same, almost the same functions. We just call it unregister. And it's not new interactable anymore, it's old interactable. And we don't need to look if it's in the list, because we basically can just say remove this object from the list, and if it's not in the list, then it's not being removed. So we don't have to change for that. Yes, so chat says a list is also slightly faster with removing and adding items at runtime. Yeah, it's true. I mean, there are tons of different containers, basically. You have a list, you can have a dictionary, you can have an array and stuff like that, and they all have advantages and disadvantages. But so it's good to know about the differences just on a base level. You don't have to know how fast each one is and stuff like that, because most of the time everything, I mean, we're working on very modern computers right now, and so everything will be fast enough. And it is, and the differences in speed of the different containers is at such basic level that you probably won't run into problems, performance problems, because you chose the wrong container type. It's more likely that you write inefficient code than that the container is actually the part that is inefficient. So yeah, so that's why don't sweat it too much. Basically, just use whatever is easier to use for this for you in the specific instance. Okay, so we have these two functions, and now each interactable has to call those functions. But now we have the same problem. So each interactable needs a reference to this model and say, hey, I can interact with you, and I'm an interactable. And so we need a reference. We need a way so that the interactables can get a reference to this, and we can use the same thing. We could do find object of type. We could find objects with tag, and our main character has the tag player, so we could do that. We could do that as well, and then our main character does not have the tag player, but so we can. But I want to do basically that. This is what I want to do. I want to give the main character a tag, and we call him player, which is actually a tag that already exists. You can add more tags as you like. Just hit add tag. You get to a list here, and then you can create as many tags as you want. But the player tag is basically a default Unity tag, and we're going to use that for our character. Player. Perfect. And now we can use GameObject find objects with tag. And this is, you could also search for an object by name, so you could just search for Lang here. But maybe you have it, I would, whenever you search for an object by name, it can be problematic down the line, because whenever you change the name and you forget and that in your code you search for this exact name, sometimes you will break your code just by renaming something. So your game will break even though you're not coding, actually you're renaming something, and so you don't know that your game just broke, which is a very bad problem to have, because then later when you get to that problem and your game is not working as expected anymore, then you don't know what you did, because you did that maybe a couple days back, and you don't remember what you changed so that this error occurred now. So this is why I don't want to search by name, because you're renaming stuff all the time, but you're less likely to rename a tag because you know that you're using those tags in your code. So yeah, it's basically, and renaming a tag is also just, it has one added step. You have to go to the list first and then rename it here. You can't just simply click on it and rename it. So it has an added step. It has a little bit of extra layer of protection so that you don't accidentally break your stuff. And basically just know if you have a tag in here, you're probably using it in your code, except maybe for the Unity tags. But once you create your own tags, you're probably using it in your code. So just don't rename tags unless you know it's exactly what it does and where all those tags are. Okay, so we're using the player tag because this stays the same at all times. And so now we can go to the interactable component here, and in our start function, so as soon as this interactable component is created, and this basically once the object is created. So maybe you can create the object at runtime, then the start function is called, or when the level is loaded and the object is in that level, it gets called immediately. So in our start function, we want to register, and we create different functions for that, because I don't like to code in the start function itself, because the start function and the update function as well, for me, are basically, they're telling me what the object is doing in plain English, because I name my functions that way that you can understand exactly what they're doing. So you basically, any coder could read my code and just look at the start and the update function, and they can basically read in plain English what the class is doing. And then if they want to learn more, they can just go to all those functions and see how they what these functions are doing exactly. But this way the class is basically documenting itself. And this is what I said in the first lesson as well, is this helps reduce the amount of comments you have to write for your code, because I'm under my philosophy is, once you use comments, your code is too complex and you have to refactor it. So yeah, this is why. So the class documents itself. So register interactable. So we can put basically the function up here, and then you see once you open this class, in the start function we call register interactable. So we're probably registering our interactable. We don't know how we do that, but we don't really need to, because we just get a base understanding of what the class does, which is pretty nice. Okay, so register interactable. We're going to look for our character and get the model on that character. So let's get the character first. GameObjects, player objects, and we call GameObject find GameObject with tag, and we are searching for the tag player. I have to find a way where this is always zoomed in, so I don't have to do this every time. So we're looking for a GameObject with this tag. If player, it may be possible that the player does not exist. So if player object is null, we basically want to throw a warning that no player found. Just so we basically, when something goes wrong and we can't find the player and the object cannot register with the player, we have a warning that this happens, and then we can find out why. Okay, from the player objects we want to have the character interaction model. Interaction model, so we want from the player object, we call get component character interaction model. It's good as well. And same thing, we're checking if this interaction model is null, because then we messed up. No interaction model found on the character, so we know, oh, well, I also have to return, because if that happens, then we don't want to go further on in this. So because if we don't have a play object, we cannot register with it, and the same with the interaction model. And now we found this, so we can call register interactable, and because we're registering ourselves, so we want to basically register the same class that we're in right now, you can use a special keyword called this. And this is basically this is always a reference to the class that you're in right now. And we want to create the same function and call this unregister. And I copied this complete function now. And now you see you have a lot of code that I duplicated. The whole getting the player object, getting the interaction model and stuff like that. We have duplicated that, which is not very nice. So this is basically a code smell that tells you, okay, you need to refactor this. What we can do is we can take all that code and create a new function for that. Character interaction model. And we call this function find character interaction model and paste all that in here. And then we return the interaction model that we found. So we do all in this function, we do all that. We look for the character. If we don't find the character, then we want to return null. So we couldn't find it. Null is returned, and we have a warning here. And we do the same for the interaction model. If we cannot find it, then we return null. And if we found the interaction model, then we want to return it. So now in our two functions up here, we can basically just do that. Find character interaction model, and then we register with it. And yeah, I have to duplicate the null checks. It's true, but I don't have to. I also checked them here, so I don't have to do the warning again. So basically, what I'm doing now, I'm just returning if the interaction model is null, because I know I already have a warning for that. So this is a little bit cleaner code. So you can see here, if you go into register interactable, this is also very simple to understand. You will see in the first line, find character interaction model. If it's null, we just don't do anything. Otherwise, we register. And this is all that another programmer that tries to understand what you're trying to do here, is all that he needs to know. He doesn't need to know how you find that, except that if he wants to learn about that. But this is basically what I mean with self-documenting code. You can understand the whole function by just reading the names of the stuff that you're doing here. And we want to do the same thing, unregister. We call unregister here. Perfect. And for now, we're calling unregister. Basically, there's another Unity method called onDestroy, which is obviously called when this object gets destroyed. And when we're destroyed, we want to unregister. All right. So let's see if this works. Basically, we're calling register, and in our register here, let's put a check in here and tell us interactable has registered, and then we also want to have the name of the interactable, so new interactable name. And also the debug log function can have a second parameter to a game object, and I'll show you in a second what this does. So basically we have the message, once an interactable registered, we have the message interactable has registered, we get the name of the interactable, and then we're doing something else here that I'll show you in a second. Let's see if that worked. I don't want to maximize once I play because I need to see the console. We have an interactable on our chest. So let's clear the console, press play, and see what happens. So our console said interactable has registered chest. So it's the name here. And because we put the second parameter in there, we can now click on this message, and then the chest is being highlighted in our hierarchy. And this is very, very helpful. If you have, imagine, I don't know, you make a Minecraft game, you have tons of cubes. It won't be helpful if a debug message says cube is not working. So this way you can have a reference in there, and once you click on the object, then it immediately gets highlighted and you see where the problem is. Cool. So, but this works basically. So the chest found the player, it found the interaction model, and it has registered. So now the chest is in our list. And so we can check this as well. Let's remove this debug log here. And once we press space, we want to say debug list of interactables. So basically we just want to, once we press space, we want to see a list of all the interactables. And so we have the list up here. So basically we can just create a loop for, let's do a for loop here, whatever. For integer I is 0, I, as long as I is smaller than the number of interactables in our list, and press I. And then we want to debug log as well. Want to have the I first, basically tell me this is the number of the element, and then I want to have the name. And again, I want to, well, we don't need this now because we remove it in a second again. We basically just want to have a list, and a list, print a list. Are you on Windows XP or older? No, this is actually Windows 7. I just disabled the skins because, yeah, I don't know. I just like the base skin. Everything was better back then. Okay, let's press play. And as soon as we press space, we get a list of interactables, and the first element is chest. And then let's we have a sign, and this is, so now you can see why the interactable method is cool, because you can we click on our sign and we add the interactable component, and we can press play again. And once we press space, you basically already have a list of interactables. 0 is sign and 1 is chest. So you just have to add a component, and boom, you have a new interactable. And this is the power of the component model in Unity. And yeah, and basically this is why I always try to create as many components as possible. Cool. So once we press space, we get a list of all the interactables in our scene. And let's add this. And now we want to we want to find which object we can interact with. So question is, how do you check which one you use? So this is what we're doing right now. We haven't gotten to that part yet. To check which object we are interacting with, we basically have to check for two different things. Are we close to the object, and are we facing the object? Those are the two checks that we want to do. So let's, for now, do it like this. We basically just go through the whole list and make the checks, and then we refactor it later and put it in functions so it's nice. Or actually, we do it right now. We do a function called find. How should we name it? Basically, I want to create a function that returns the interactable that we can interact with. And we can always just interact with one. So this function basically already checks which one is the closest, which one is available and stuff like that, and just gives us one interactable that we can interact with. So while find interactable is not very descriptive. We can just call it find valid interactable. I think this is good. Find usable interactable. Yeah, I think usable is even better than valid. Valid is just it's a little stiff. Find usable interactable. That's a good name. Thank you. And we basically what we do in that in this function is we go through the list of all the interactables, and then we check each interactable for those conditions. Is it close to us? Are we facing it? If yes, return it. Find interactable. Yes, that's, well, it would tell what it means, but yeah, it's not very good English. I always strive to name my functions in a way so you can basically write them down and it looks like plain English. So yeah, find interactable is a little obscure, I guess, but yeah, I know that you're kidding, so it's fine. Good. So for each interactable, we are checking first, are we close to the interactable? And we could do that with distance. So I can show you, for example, we can check the distance. Let's see how this works. So distance to interactable, and Unity provides us with cool helper functions for that. So we can put vector3 distance and then put two vectors in here, and it gives us the distance between the two vectors. So we want to have the distance between us, transform position, and the interactable position. Interactable transform position. Let's make this a little smaller here so we can see more of the code. Now we can actually put this on the new line here. Okay, so we want to find the distance between the interactable and ourselves, and then we can add this to our debug statement, distance. So this is a possibility. So on interact, we basically interactable, usable interactable, and then we call find usable interactable, and then if usable interactable is null, then we don't want to do anything because we don't have a usable interactable. But yeah, I basically just we need to call this method here. So let's see what this does. Once we press, oh, there's a bug here. Let's see what is wrong. Not all code paths return a value. Oh, okay, fine. So the problem here is that find usable interactable is supposed to return something, but there is no return statement anywhere. So for now, basically we just want to return null. And this is enough for now, and we expand this later. I mean, this is basically also what I want to do. So find usable interactable, it goes through the whole list. If we find something, we return it. If we don't find anything, we reach the bottom of the function, which basically tells us we didn't find anything, return null. Let's press play here. I like how you teach as you code. Thank you. I'm glad that it's useful and we can get something out of it. So once we press play, you can see here we have our interactable sign. The distance is 8, and the chest, the distance is 3.7, blah 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 blah. And if we get close to the chest, and run into it and press space, you can see the distance to chest is 0.9. And we could use that. But the problem is we're basically checking the distance from our center to the center of the object. And imagine one of those trees is interactable, and we now say, okay, when we run against it, the distance is smaller than 1. We could do that, but imagine one of the trees is interactable. So we run to the tree, make it interactable, and the center of the tree is further away. So the distance would be greater than 0. This wouldn't work because then, it would be greater than 0, greater than 1, and our check wouldn't work. What we actually want to do is we want to see if the colliders are very close together. So you can see here, if we select the chest, we have well, it's not very visible, but you can see the collider here, which is the square, and our character has a square as well. You can see here. And basically what we want to check for is, are these two colliders very, very close together? And there's a way to do that. Unity has very many helpful functions here. So distance is not exactly what we want, but still we leave that for now because it's something that we're still going to use, but with different input vectors here. So basically we want to find a point on our collider that is closest to the other object. Let me press play again. So now we basically want to find a point on the collider that is very, very close, very close to the other object, right? So we're going to do that by, first of all, let's start by getting the point on our collider that is closest to the chest. Right? So the transform is in the center here, and we want to find the point on our collider that is closest to the center of the chest. And in this instance right now, it would be probably the corner here, maybe a little bit further down, but somewhere in this area here. And in order to do that, we need a reference to our collider, and you can see here our character. The collider is basically on the main object, and the interaction model is on the main object as well. So the collider is on the same object as our component. So we can simply do a get component here. Private. We want to have collider. We want to have a reference to our collider, and we get that reference in our start or. Well, I always get references in awake functions. Awake functions get called before all start functions. So I set up references in awake, and then I do my starting logic in start, so that I know all references are set up correctly. So collider. No, I want to call properly collider, and then get component collider. Okay. So first of all, we want to find the object on the closest point on our collider. Closest point on character collider. We get our collider, and it has a function closest points on bounds actually. So we don't have to do a lot. Basically, we want to find the closest points, the point that is on our collider that is closest to the interactable. This is what this function does. So now we have a point on our collider right here. Let me select the chest again. Now we have this point. But the distance to the center of the object still could be an arbitrary length depending on the size of the object. So now that we have this point, we actually want to find the closest point on the collider of the interactable that is closest to the point that we just found. because those, whenever we are touching, those 2 points will be very close together. Even if we go to the other side here, we basically call find closest point on collider first. So find closest point to the interactable, which will be here, and then we will find the closest point on this collider to this interactable, so it will be here somewhere. So they will be very, very close. They won't be touching, as you can see here. They're not completely touching. This is a physics thing. They have a little bit of a boundary between them, but they're very, very close. So is a raycast not an idea to get the object? Yes, a raycast is a different way, but a raycast is also a physics operation, and physics operation can get expensive if you do many of them. And imagine again, you have a scene with 10,000 objects, and you're raycasting to all of them. I mean, you could check first if they are close together, and only do a raycast if you like in a proximity. But still, it's the same thing. So how close is close? What really is close? So yeah. So I think this method here actually is very, very efficient, because this way we can find out if our two colliders are basically very close together, which is exactly what we do want to find out. So our second vector is vector 3, closest point on interactable collider. So now we want to find the collider of the interactable I, this is the one we have on our list, and get its collider. Well, this could be null as well, so let's do that first. We have to check if the interactable actually has a collider. So interactable collider, get its collider. And if the interactable doesn't have a collider, we cannot interact with it. We just decide. This is our design decision that we have right now. It needs to have a collider. Interactable collider. If it's null, then we just type continue. Continue is similar to return, but return would exit out of the complete function, so we would stop looking for an interactable. But there may be different interactables in our list afterwards that are valid. So this is why we call continue, because this basically means we're done with this iteration in our list. Go on to the next step in your loop. So yeah, this is what continue means. So now we have that. We want to find closest point on interactable collider. Same thing. We can copy this line here, but we're calling this on the interactable collider, and also we are using our closest point from before. So now we have the 2 points that are on the 2 colliders that are closest to each other, and we can use those in our distance function here. Shouldn't it be a collider 2D, or does that inherit from collider? I think it inherits. If not, we'll find out now. But I think a collider 2D is also a collider. I think we can. Let's see if we can find this out this way by just going in here. A box collider 2D is a collider 2D, and if we click on here, a collider 2D. Oh, okay, so it's different. Yeah, good catch. So it actually has to be a collider 2D. This was a good catch. So we have to do a collider 2D in here, and we also have to do a collider 2D. Oh, it doesn't have the closest on bounds? That's not good. Oh no! Now I explained all the system, but it doesn't actually work because this function does not exist on a 2D collider. So, what do we do now? I don't want to write that function myself because it's a very complicated function. I actually so what we can do now is different things. We could do the way that you proposed before. We can do a raycast, which is fine, I guess. And we can see. Let's do a raycast for now. This is again the same thing as I said before. Don't optimize something that's not bad for that's not working right now. So let's just do a raycast. We are raycasting to all objects and see if we are close to it. And this way we found out different methods. So the closest points on bounds is the closest point on bounds is a good method. I used that before for 3D objects to see if they're touching, and it's very, very efficient, very fast. But yeah, for now, let's just do a raycast. So this way you get to see two different methods here, which is also fine. So this whole thing, I don't know if we need anything from that. So let me just comment that out for now, and we can remove it later if we don't need it. So a raycast is actually a physics operation that that shoots a ray from a point, shoots it in a direction, and tells you if it collides with anything. So, and we can, you can either check if it collides with a specific object, or you can shoot in any direction, and you can shoot in any direction, and it will tell you which object it hits first, or even which objects it hits, and it goes to infinity. So there are different stuff you can do with the raycast. But what we actually want to do is we need this. We just want to raycast to the collider, and we ignore all the other colliders. We just want to raycast to this collider and see if we are hitting or where we are hitting this collider. So interactable collider, we're still checking if the interactable actually has a collider. Wait. Okay. So once we have that collider, we can do a physics 2D, and then we do a raycast. And the raycast needs an origin, so where do we start? And it needs a distance and where you're casting to. So the origin is actually our character, our current position. Transform position. And the direction is, we need the direction to where our other collider is. So let's get this first. Vector 3 direction to interactable. And to get a direction, basically if you have 2 points, if you subtract them, you get the direction from this. So the first operand is basically our target, and the second one is our starting vector. So M interactables I transform position, and we subtract our current position from that. And this way we get, so we have a target position, we have our current position, and if we subtract, then we get basically the vector that is between them. Basically exactly the direction. We don't know the size yet, but that is not so important actually. We only need to tell the ray go into that direction, and we tell it the distance in another parameter. So we have the raycast, we start at our position, we go in the direction to interactable, and then we can also say how long do we want to travel, and we are going to travel for the length of the direction, because if we move past the length of the direction, we're past the object anyway. So direction to object, so this is the magnitude. Let's make this a little nicer here, and yeah, that's actually, this is it, and this returns a raycast hit 2D, and this hit object is basically has all the data for that. So we can see here. Let's go into the hit object. We can see what we have. We get a centroid. We get a distance. We get the collider that we hit. We get the point that we hit. We got the normal that we hit. Stuff like that. So we get a lot of data from our raycast. What we actually hit. So let's debug some of that data so we can see what data we can use for our purposes, actually. So let's see, for the interactable, we hit, let's see which objects we hit first. Hit, collider, name. Okay, so whenever we press space, we're shooting a raycast to all the different objects, and we get a return value, so the console is supposed to tell us what objects did we hit. Press space. Okay, so now you see the first problem. The raycast always hits our character, which makes sense because we're starting in the center of our character and we're shooting a ray, and the first thing that we hit is ourselves. So this is not good. We need to remove ourselves from this raycast, and there are a couple of ways to do that. I think the most efficient way is there's a way in physics where you can say I want to ignore a specific type of players. So here's a very good question. Okay, this snack brings up a major question I was waiting until the end to ask. Why have you chosen to register all the interactables with the player? Why not spherecast all to get interactable objects in the local area? This is a very good question. It is another method. So when coding something, you have tons of different many different ways to achieve the same effect. I chose to register the objects. Well, it's really, to be honest, there is no real reason for that other than that is the way that I came up with to do it. Using the spherecast is actually a very good idea. So let me show you guys what Alucard is saying there. So we could also do I think that's a physics thing, right? Physics 2D. We can use an overlap area or overlap circle, which basically and then overlap circle all, which basically we give it a point, we give it a radius, and it gives us back all the colliders in that area. So we could basically say in our center and then make a little circle that is a little bigger than ourselves and get all the colliders in that area, and then we can check if those colliders have an interactable, and if they do, then we can interact with them. And to be honest, now that we talked about this whole method, I actually like your method better. Because it's much simpler. You don't have all the register stuff. But the thing is, that's no problem. We haven't wasted anything. I mean, the method that we chose is actually is a valid method, and yeah, there are different stuff to do, but yeah, the thing is that your method actually is way easier to understand. I think you basically find all the objects in the center and see if they're interactable. I like that a lot. Well, I can admit defeat. That is fine. I don't know. When I planned this today's lecture, basically, I came up with the other method. Thought, I mean, there's some couple cool concepts there, registering with stuff, finding different objects. So it's good to learn something. But your method is very good. So let me see here. You guys have actually more ideas. So my idea was just shoot array a short distance in the direction you are moving when pressing the interact button. Then if it hits an interactable object, the object determines if it hits from the correct direction, and if you... What? Then if it hits an interactable object, the object determines if it is hit from the correct direction, and if you interact with it. Yeah, different method. See? So we actually now came up with 3 different methods to achieve the same effect. We can have a list and check through all the boxes. We can have we can shoot. So every frame we can shoot a raycast and see if we hit something. Or not even every frame. Just if you press space, just hit a raycast in the one direction and see if you hit something. And if you do, then yeah, and if you do, then see if that object is interactable. Or you can use the overlap sphere. I still like the overlap sphere better actually than the raycast, because maybe there can be objects later on that you can interact with even though you're not looking at them. And also you have the same problem that we have right now. You're actually you're colliding with yourself first. You have to use physics layers, and I don't want to introduce the physics layers now, because then you have a bit mass comparison, stuff like that, which is a complicated topic, and I actually didn't want to have that in my code. So that's why that's why I decided the method that I used here, because it doesn't use the raycast. But yeah, so let's. I think let me. Okay, let me implement the overlap circle method, and you will see why this is so much simpler, and I wish I had thought of that before, but it's fine. So, very quickly, because we can basically do everything that we did in 5 minutes. So on interact, we are find a usable interactable, which is fine as well. We don't need our for thing here. We basically use the overlap circle from a 2D point, so we want to start from our position, which is actually a 3D point, but it works because Unity does that for us. The radius is, let's just use a radius, I think 1 should be enough. A radius 1, and yeah, we don't need a layer mask. So this is basically all that we need. By doing this, we get a list, an array of collider 2Ds. There you go. Close colliders. So we get a list here, and let's see if that works. So let's bring our for loop back and just loop over all the colliders. And now we don't actually, so there's a different name here. So this is an array, as we talked about before, and we have a list up here. And the array has the property length, which is the same as count in a list, which is too bad that there are 2 different names, but there you go. So we go through all the colliders. I don't like that resharper just makes stuff dark if it's not needed yet, because it's very hard to see and stuff that you're working on. So close collider, and then we just debug log I again, and name. So basically what this does, see which colliders are close by first. It can be size, the small sphere can be the size of the player, which is about right. So the player is a little smaller, but so this is fine. Let's press play. So when I press space, we find ourselves always, which is good. If we run next to the bush, we find the bush and we find ourselves. Here we find ourselves, we find a stone 1 and we find a stone 3. So this is actually a very, very nice method. It works very well. It basically finds objects that are close to us, and then we can check on these objects if they have an interactable. So great. Basically in 3 minutes we used a function that Unity provided for us, and it does everything that we tried to do in the last hour and a half, which is often what happens when you code in Unity. You do something the hard way, and then you find out, oh, there's a helper function for it. But that's fine. I think we learned some good stuff along the way. So it's not checking if we're facing yet. That's true. We need to do that. But we can do that another way. The first of all, since this is working so well, I will remove the old code. So refactor, remove what we don't need anymore. So we actually don't need a lot of it anymore. We don't need the list of interactables. So we don't need the functions register and unregister. And actually, deleting code is a very, very good sign. If you found a method and you can delete half the code that you did, it basically immediately says this is a way better method. So we go into the interactable. We don't need to register the interactable. Okay, let's remove that. Let's remove that. Let's remove that. All right, on interacts, we find it, and so close colliders. So from the close collider, we want to see if there's an interactable here. Interactable. Collider interactable. Basically, we want to get component interactable. And if we find a collider here, same thing actually. If the collider interactable is null, then we want to go on to the next thing. Continue. If we have an interactable, we now have to do the next check. So we now found an interactable that is close to us, and now we need to see if we are facing the object. And to do that, basically Unity gives us a couple of different vectors that we can work with. So first of all, we need the direction of the object itself. So that's the same thing that we did before. Direction to interactable. It's basically we subtract the two positions from each other. This is the close colliders now, and we get the transform position minus our own position. Delve Zero, if you're using a layer mask, you don't need to check if it is interactable, and you will not ray hit yourself. True, but as I said before, then you always have to do two things when you create an interactable. You add the component to the object, because it needs some functionality. How is it interactable? And you also you also have to set it onto an interactable layer, and you can forget that. You can also, maybe you need the layer part for a different for some different functionality. So using the layer here is actually, I don't like that too much. So that's why I use the component system, because this way we can make something interactable, we can later make it destructible, we can basically have components for every attribute that an object has, and we can have as many as we want. So so we found the direction here. Close collider name, and then also we have in our transform we have different vectors. We have a vector forward, we have a vector right and stuff like that, but that actually doesn't help us too much, because we set our code up in a way that it's always facing the right direction. So we actually have our direction stored in our movement model. Maybe you remember from our first episode, the control sends the movement, basically set direction. It sends the movement to the player in which direction we should move, and then we store the direction in our model. And we have a get direction method here as well. So we simply need a reference to our movement model. And since our interaction model is on the same game object as the movement model, we can simply do a get component again, private movement model, and then we do a get component character movement model. And once we have that, we can actually have the get direction here. So now we have two vectors. We have the direction we are facing, and we also have a direction to the interactable. Now we want to see if they're basically the same. So what we can do here, there are again many different methods we can use in Unity. One of those methods, for example, is we can get an angle to interactable, and this is a simple vector 3 angle between it basically, if we have two directions, it gives us the angle in between here. So we get out the direction from our movement model and also the direction to interactable, and we get the angle, and let's debug that. Press play. Now if we hit space, nothing happens, because we have our check in here if the collider has an interactable, and our lung character doesn't have an interactable on it, so that's why it doesn't show up anymore. But if we get close to the chest, you can see the chest is coming up here, and actually there's an angle of 90 degrees right now, so we have to check. It's always 90? It's always 90. Let's see what's going on here. Let's debug our two. I mean, yeah, you guys are talking about Unity VS in the chat. Sure. I mean, we could use Unity VS to check all these variables. It's a good tool to use. I don't have it installed right now, so that's why we're using the debug logs for all the different stuff here. But there's an easier method. It's a free script called Unity VS, or I think they renamed it once Microsoft bought it. I think it's just tools, Visual Studio Tools for Unity or something like that. And this way you can you can pause your game, go into the code editor, and then see what the values of the different objects are. But for now, this is all right as well. So let's see why the angle between the two is always 90. Which is not something that should be happening. That is because one of the two vectors is always 0. Except if we walk. Okay, so the direction is actually if we stand still, then the get direction gives us a 0 vector zurück. A 0 vector, but we also want to so we want to get the facing direction. So what we can do in our model is that we can either store that as well, because we can store that as well. So private vector 3 m movement direction, and we have m facing direction. And basically what we do in set direction is, if the direction is not 0, then we want to store the direction in the same that we set up for the movement direction. We want to store it in the facing direction. Oh, it's a vector 2. And then we can also basically get vector. I always use vector 3. It's just and then we do a get facing direction. Facing direction. Okay. Go back to the interaction model and then use get facing direction instead. Okay, let's see. So now the facing direction is not 0, which is good. And then we can see the angle between the two. I mean, you can see here. So the angle right now is, if we look away from it, the angle is almost 170. If we look close to it, it's 3 right now. So the reason why it's not exactly 0 is because the direction that we are looking at is it's not the normal of the collider, but actually the direction to the center of the chest. So we're comparing our facing direction, which is one of 8 values. So it could be diagonal, it could be straight, and we're checking that with the vector that can be any of the 360 angles here, because right now it's a little bit crooked here to the center. Basically, right now it would be pretty straight like this. So we still have to we still have the problem that we can't really say if the angle between the two values is 0, then we want to interact with it. We still have some wiggle room in there. So, for example, as you can see here, it's now 37 degrees. So, I think a good value to check would be, is it smaller than 45 degrees? Because then basically in 45 degrees in both directions, we can interact with stuff. And combined with the check we had before with the overlap sphere, asking are we really close to the chest? I mean, we could fine tune the overlap sphere a little bit, because as you can see here now it's still triggering here because the overlap sphere is maybe a little bit too big. We can fine tune it a little bit to bring it in, and then we can use the 45 degree angle to just check if it's smaller then. Or you can use 40 degrees, something like that. I think that's fine. So basically what we check is if angle to interactable is smaller than 40 is fine, I guess. Smaller than 40, then we want to return this interactable, because then we found one. And basically, it's possible that there would be another collider very close by in our list that we want to interact with, but we can only interact with one. So what we can do is we return it now, and then we don't check anything else, which is maybe not the nicest method. What we also can do is we store this collider, and we store the angle it has, and we continue with other colliders. And if there's another collider that is also in range, but it has a smaller angle, then we use that instead. Exactly. Find the smallest one. So what we can do is we store, we create two more variables, close, that's closest interactable. For now it's null, and then float angle to closest interactable is, for now, it's because we're starting out, we don't have an angle, and we set it to the value infinity, which is the biggest floating value it can be, because then we can always check if is the angle smaller than before, and whatever angle comes up first is always smaller than infinity. So first we check if the angle is smaller than 40, and then we check is angle to interactable smaller than the angle to the closest interactable. And if that is the case, then we set our closest interactable to the current interactable that we have, and the angle to closest, and we have to store the angle as well. So this way, this variable always has the closest angle that we found, and in the end we know that the closest interactable is in this variable, so we can return that. And if we don't have any interactable, if we didn't find any interactable in here, then the value would still be null, so it's the same result as we had before. So if two interactables are pressed against each other and you're in front of the first one, would this method ever accidentally select the second one? I'm not quite sure what you mean by pressed against each other. I mean, our overlap sphere, we are bringing it in a second a little bit. We have to check actually the size that we want to use. And then I don't think that that will happen actually, and because the angle, if there's one that is two that are very close together, I mean you could be in the very center of it, and then it's basically random which one you choose. But I think a player would understand that you're in the and it's very unlikely that will happen, that you're in the exact center. So I think this method is good enough actually. Okay, so one more thing, we need to find the size of our overlap circle, but we can do that next time. So for now, we found our closest interactable, and then if we have this, found interactable, and then put the name in here, bam. Okay, so let's press play. So it should, when we walk up to the chest now and press space, it says found interactable chest. And the same thing. If we found nothing, if we press space here, and if we go close to the sign, we'll find the sign. which is beautiful. This is exactly what we wanted to do. So actually, we're above the time for today. So I always stream like for 2 hours to do this. So sadly, we are already over our time. So yeah, I mean, next time, Alucard, you could have asked while I was doing my other method before. That would be no problem at all. Don't wait if you think you have a better idea than me. I mean, as we saw, there are many different ideas you can, in many different routes to achieve the same effect. And I won't say I don't always have the best idea that works. You saw that clearly today. So whenever you have a better idea, and whenever I do something stupid, please do tell me, and then we'll fix it together. All right. So, but yeah, basically, so what we did today is we wrote 2 different methods on how we can find interactables, and the last one that we did is actually working perfectly. If we are looking away from the chests, you can see we can press space. It doesn't trigger, and as soon as we look towards the chest, it triggers. Yeah. So this is I think this is a perfect starting point for next week. So we can start working on the different interactables. So we have a chest here, and once we can open that and get the shield. We have the sign here, so we can read it, so some text will pop up when we interact with that. And also we have the sword here, and when we interact with it from here, then we can also we receive the sword. So I think that's the cool something cool we can do next time. And yeah, so I'd say thank you very much for watching all. I hope you enjoyed this, and you saw a very fundamental thing about coding is that there are many different ways to get to the same goal, and there are always people who have ideas that are probably better than your ideas. So yeah, talk to people, and it always ends up being better. Your code will always end up being better if you brainstorm with other people together. But it's cool. I mean, this is we developed this game together, so I'm very happy that this happened actually. So because now we made it better together, which is very cool. I'll upload this the code for this in a second when I stop the stream. I push this to our repository. You can find the link below the stream. Actually, I can post the link as well in the chat again. It's on GitHub, and you can get the code here. And then next time we'll interact with some objects. Okay. So, but now I also want to show you, just to basically close out this, I want to show you the amazing music that my friend created for us. I mean, you maybe heard it in the beginning when you were here, but let's play the music, and I see you all next Saturday at the same time and at the same place. And goodbye, everybody.